In April 1815, a mountain on the island of Sumbawa began to tear itself apart. Mount Tambora had been quiet long enough for villages to grow on its slopes and for traders to move through the region without thinking of it as a global threat. Then the volcano woke, with explosions so violent that people hundreds of kilometers away thought armies were firing cannon. The first blasts were only warnings. On the evening of April 10th, the eruption escalated into one of the most powerful events humans have ever witnessed. Columns of ash climbed into the stratosphere. Pumice rained into the sea. Darkness spread over nearby islands in the middle of the day. Hot avalanches raced down the mountain and erased settlements before many residents understood what was happening. Tambora was not simply erupting, it was removing a large part of itself from the map.
Before the disaster, Tambora was a tall stratovolcano, likely over 4,000 meters high. Afterward, its summit had collapsed into a huge caldera. The eruption ejected tens of cubic kilometers of material, far more than Krakatoa would throw out decades later. The local death toll was catastrophic. Many people died in the immediate blasts, pyroclastic flows, and tsunamis, but many more died slowly afterward. Ash buried fields and contaminated water. Livestock starved. Food networks broke down across Sumbawa and neighboring Lombok. Reports collected by colonial officials described villages reduced to ruins and survivors searching through ash for anything edible. The volcano had destroyed the ground beneath their lives, and then it began to affect people who had never heard the name Tambora.
The key was sulfur. Tambora injected huge quantities of sulfur dioxide high into the atmosphere, where it formed sulfate aerosols. These tiny particles reflected sunlight and changed how heat moved through the climate system. The result was not an instant frozen planet, but a dangerous distortion of weather patterns. In 1816, the Northern Hemisphere entered what became known as the year without a summer. In New England, hard frosts struck in June. Snow fell in parts of the northeastern United States and Canada. Farmers watched young crops die, replanted, and then watched them fail again. Newspapers recorded impossible weather, ice in summer, cold rains that would not stop, and skies that seemed permanently strange. A volcanic explosion in Indonesia had become a crisis in fields half a world away.
Europe was already fragile. The Napoleonic Wars had recently ended, economies were strained, and harvests mattered more than ever. Then Tambora's climate shock arrived. In Switzerland, Germany, France, Britain, and Ireland, cold rain and dim sunlight damaged grain, potatoes, and hay. Food prices rose sharply. In some regions, desperate people rioted over bread. In others, families left their homes in search of work and food. The crisis helped spread disease because hunger weakens bodies, and crowded movement helps infection travel. The eruption did not act alone. It landed on societies already under pressure. That is why its effects were so severe. A remote volcanic event became a multiplier of every existing weakness.
The strange weather also changed culture in ways people rarely connect to geology. During the cold, wet summer of 1816, Mary Shelley and other writers stayed near Lake Geneva, often trapped indoors by relentless rain. In that gloomy atmosphere, conversations about science, life, death, and electricity helped inspire Frankenstein. Artists across Europe painted vivid sunsets, some possibly intensified by volcanic aerosols scattering light in the sky. These are not the main tragedies of Tambora, but they show how deeply the eruption entered human experience. It touched food, migration, disease, art, and imagination. A volcano can change more than temperature. It can change the emotional weather of an age.
Scientists at the time did not immediately understand the full connection. Weather records were scattered, global communication was slow, and volcanology was still developing. Many people experienced the cold year as a mystery or divine punishment. Only later did researchers connect historical accounts, ice core sulfate layers, tree ring growth, and climate models to reconstruct what happened. Ice cores from polar regions preserved chemical evidence of the eruption. Tree rings showed stress in forests. Written records described failed harvests and unusual cold. Together, these clues formed a chain from Tambora's crater to farms in Europe and North America. The disaster became one of the clearest examples of how Earth's systems are linked.
Tambora also forced a difficult lesson about scale. People often imagine disasters as local. A town floods, a city burns, a mountain erupts. But Tambora showed that a single geological event can cross oceans without moving as a wave or an army. It crossed the world as chemistry, sunlight, hunger, and price. The people who suffered in 1816 did not see the eruption. Many never knew why the seasons had betrayed them. That makes the story especially unsettling. Some disasters announce themselves with smoke on the horizon. Others arrive as failed seeds, empty barns, expensive bread, and a summer that simply never becomes summer.
Today, Tambora is studied not only as history, but as a warning. Modern monitoring can detect restless volcanoes, but civilization is more connected and more dependent on stable supply chains than ever. A major eruption in the right place could disrupt aviation, agriculture, trade, and public health on a global scale. Tambora does not mean the world is helpless. It means the planet is not divided into separate compartments. A mountain in Indonesia changed harvests in Vermont, famine in Europe, disease patterns, literature, and the color of sunsets. The volcano that made summer disappear reminds us that the Earth can connect distant lives faster and more brutally than any empire ever could.
The human details are what keep Tambora from becoming only a number on a scientific chart. In villages near the volcano, people faced falling stones, choking ash, poisoned water, and the disappearance of familiar paths. Boats encountered floating pumice thick enough to slow travel. In places where rice fields had supported communities, ash turned the surface into a gray, sterile sheet. Far away, a farmer in New England or a family in the Alps did not need to know anything about Sumbawa to feel the same chain of consequences. The eruption linked them through atmosphere and food. It reminds us that climate history is not abstract. It is the story of meals missed, journeys forced, children weakened, and decisions made under a sky that no longer behaved as expected.
Tambora also changed how later generations think about risk. The eruption was not the largest possible volcanic event, yet it was large enough to disturb weather across continents. That means volcanic danger cannot be judged only by the number of people living beside a crater. A remote volcano can become a global problem if its plume reaches the stratosphere and its chemistry is right. The lesson is uncomfortable because it expands the map of responsibility. Monitoring, food reserves, emergency planning, and honest public communication all matter. Tambora's crater is quiet today, but the record it left in ice, trees, documents, and graves is still speaking. It says that the planet's hidden connections are powerful, and that a distant mountain can enter history through everyone's weather.